Happy New Year, everybody! In the first lesson of 2025, we will discuss surface flow. More specifically, we will explore how to create a good flow across multiple surfaces using a curve network. A few months ago, I made a video about the cross-align approach, but that method is only valid when surfaces are already properly placed, meaning it was more of a refining technique. And if you don't know what I'm talking about, I'll put a link to the cross-align video in the description. This time, however, we will create the proper curve network for a good surface flow, which can later be enhanced with cross-align for an A-class pass. So what you're looking at is the model which we'll be working today. And basically recreating. It's just a random form for me. It resembles, I don't know, a canopy maybe for a plane. Or a fighter jet, or maybe it is an overmold piece for some kind of handheld device. Who knows? Doesn't matter. But its structure and its flow is actually pretty decent and pretty good. And we will recreate it. So let me just delete all of the surfaces, and I will delete these two very, very important curves. We will reconstruct them. So, and yeah, if you're interested in replicating what I will do for you right now, I will put a link to this file into the description to this video, so you can use my curves and try it yourself. So let's start with the curve network. Now, as you can see, I left only with the boundary representation of the piece I need to model. Now, the reason for that is, in general, when you start fresh, which means you don't have any scan data, you don't have any reference, mesh, nothing, just a sketch. In the sketch, the cross sections is actually quite painful to do because they are rarely realistic enough for using for a guide in 3D, especially when we're talking NURBS modeling. So the boundary, though, is quite easy to do, specifically in Sketch. So the chances that you can have a sketch, you made a sketch where you have the front view, the top view, the side view, is quite common. And these lines, so the edges, is actually quite easy to replicate and actually use them directly from your sketch. But all the inner parts, yeah, that's a little bit trickier, because even though that you can just create your squares here relatively simply by just guessing, right? Guessing where your line will go, like maybe it's here, or maybe it's here, or maybe it's here, or maybe it's just, 3 degrees and just go some other way, maybe somewhere here, who knows, right? We humans are actually pretty good at that, but not good enough. So we need to have some guide, some ability to construct the curves the proper way, knowing that the curves we constructed accommodates the our curve network as a whole, and we know that we will create a surface, it will flow the proper way, it will be constructed the proper way. And this is basically the meat of this lesson. Now, before we start, a quick note about the curves you're already looking at, specifically at the bottom one. Now, the bottom curve, as you can see, has 3 segments, but originally it has only one. This is it. So what I did is I split it on 3 different parts. And I split them because the top part, the correspondent part, has 3 parts as well. So we have 3 segments on the top and 3 segments on the bottom. Now, that's not always the case. There can be situations where you have 3 on the top, 5 on the bottom, and you need to deal with that. And I probably will do a different video of how to solve these a little more complex issues. But as for now, we're talking specifically about the proper surface flow. It's not really that relevant. But the what's important here is that these parts are cut at a very specific parameter. Let's say it was a parameterized. Sorry, let me put the wire a little bit away. Okay, so it cut at the specific parts. And first of all, it's not just detached. We have a specific tool in Alias called detach, which you're going to use to split your curves on 2 different parts, and they will maintain continuity. but I didn't use it. And the reason for that is that the amount of degrees here, if you look closer, you see this curve has 3 degrees, and this curve has 3 degrees. This has 5, and this has 5, this has 4, and this has 4 as well. So I have a different amount of degrees for different sections. And to achieve it pain-free, I actually used a different tool called fit curve. And here I want to quickly demonstrate in case you don't know what this tool does. So you can click on a curve, and when you see the intersection, it snaps, and now I have a segment. And I can define how many degrees for the segment I really need. You need to be aware, though, that these segments are not necessarily continuous. So continuity in this regard just it's not guaranteed. It may be continuous, it may be not. So you need to check it and tweak it in case you really want to use this approach. So now let me actually delete this, and we will get back to our main curve network. So where should we start? Now, first of all, this piece is just half of a model. So this model is symmetrical. That means that the other part is literally the same, and I need to maintain tangency for these parts on the one side and tangency for the another side, and in return, as these objects are symmetrical, I will get a curvature. And this is one important thing. Another important thing is my goal is that I really want to flow with the way that it will be natural for this boundary, but at the same time, I would like to have some level of control in case I want to bias some things here and there. Right, so didn't I miss anything? Oh yeah, one important thing about the cut. So I said that there is a specific parts where I cut this, and I did it using the tool called line perpendicular. It's in the key point curve toolbox. So here how it's done. So here, as you can see, where in the intersection is, the line has been separated. Same here. Now, why I did this? Why I did it specifically this way? Why I didn't really guess? Well, I wanted to have one of the angles perpendicular. Why I need a perpendicular edge? Well, in general, you kind of don't, but the edge or the angle between the two surfaces which you want to create a continuity or continuous transition, they better be under the 90-degree angle. If they don't, Alias can handle it just fine, but to some extent. So if the angles will be too wide or too narrow, you may have problems, right? So if I will do something like that, for example, right? I'm exaggerating things, but you get the point, right? Yeah, it will be really difficult for me to use these parts, especially here, but everywhere, because the angles are too extreme. So ideally, what you want is to have a natural and really good angles which are relatively within the 90 degrees plus minus like 30, something like that. And then you will be just fine. It will be easy for Alias to align. Of course, it doesn't necessarily mean that you always will be able to do so. In the situation where you have a skewed curves, it is impossible to maintain 90-degree angles at all connections. I believe it's quite obvious. So you will pick one, basically. One if at the 90 degree, another one probably will be not, like these ones, but they're still within the manageable limit. So that's why they cut this way. Right. Now, this out of the way, let me actually start laying down the surface. Now, why I'm starting with the surface? Because I don't know where the curve is supposed to be. If I will start with the curve, I will be guessing. So instead of that, I will start with the part which has more than 2 edges. So right now I have 3, so 1, 2, 3 lines. This is perfect for the tool called rail. So I will activate the rail, the 1 generation curve and 2 rails, and create myself a surface. So this surface has some issues. First of all, we don't have tangency on the other side. So if I will, flip it on the other side, you're going to see we have this peak. so we are not accommodating for the tangency, which is a bad thing. We need to fix that. On top of that, I don't believe that this arc is actually, it's natural for what we have, but if there will be the tangency, the lines will follow completely differently. So this edge can't be treated as a proper edge. On top of that, if I look closer, you will notice that the line itself is not straight. So it bends, and I would like to have a straight edge. So we need to fix this also. So even though it's somewhat natural, it has a linear transition, it doesn't really serve as well at this point. So we need to tweak it. Now, first of all, let's fix the tangency. So if I will activate the history, I can use the option called imply tangent for one of my sides. I will use the rail one, so this side. Now, this imply tangent is actually it's rarely desirable to do so, but I still want to show you what it is. So if I'll click on imply tangent, it basically maintains the tangency, but it changes the flow of the CVs. So now the distance between the first and the second CV is actually different. And it based not on my intents, but on the Alias algorithm. And if I actually activate the surface fillet controls, just temporarily for the fillet tool, there's supposed to be, where is this? Oh yeah, I need to actually create, just temporarily. So there is the, there is these options for the tangent scale. So the distance between first and the second CV row and the second and third rows, they call the tangent scale and curvature scale. So this is the distance, or you can call it a lead-in, which automatically creates by Alias based on its own algorithm to create a better flow. But it's just an algorithm. It's not necessarily works for you. Let me just delete this. So when we have these really odd placement, it's not something we really want. So instead of using implied tangent, we can work with a different approach, and this is a separate additional guiding curve which you use to create a guide surface. So right now, for example, I will use the one generation curve and one rail to create this guide surface for me, and then when I activate it, actually I need to undo it and quickly create it again. So first, oh sorry, this one, and this one. So now for the rail one, I can switch it strictly to tangency, and that's better. So now we have the proper direction. The only thing is missing is that the collinearity, but we can easily tweak it by using the specific checkbox. Now that's great, but I actually want to show you a different method of doing so. Now, when you have this technical surface, you need to create the curve, you need to create the surface. The surface is always supposed to be in front of you, so you need to align it. If you delete the history for your rail, the alignment just goes away, so you need to redo it again, and so on and so forth. So even though this is a really prominent way of doing it in the industry, I would say that the better way of working across the symmetry is using a different tool called symmetrical alignment, or I believe it's just called the symmetry plane. Yeah, symmetry plane align. So the symmetry plane align by default takes the default symmetry plane, and you can use it to align one object symmetrically across the center line. So how are we going to do it? Let me actually delete this. Let's just actually delete this and do it again. So rail tool, one generation and two rails. So like that. So we have our original surface, and now I will activate my symmetry plane, and I will pick, so I need to select this surface one more time. It will destroy the history for the rail, but we don't actually need it anymore. So I can hit yes. And as you're going to see now, it is tangential, because you're going to see that all of the CVs are collinear now, they're in line. And that means that there is if I will flip this surface on the other side, I will maintain a continuity, a curvature continuity, right? And that's because the surface is under the symmetry. And what's cool about all of this is I can move these CVs, and the history will maintain the continuity. So now when we have when we have this, I can go from the side view and solve the second issue. And the second issue is the fact that we have a skewing here. So as I said before, we need straight edges. It will be much simpler for me to align later. So it's not technically really necessary, but it's better to do so specifically, but in this situation specifically. So let me just do that. So click on the edges. Actually, I forgot to switch it to closest boundary. Okay, so, and as you can see, even though I used a different tool, we are still under the history and there is no issues. If that was a rail tool and it was aligned tangentially to this surface, and I will use the planarize hole command, it will destroy my history, and the continuity across the central line will not be guaranteed. But as we have the different tool, the symmetry plane align, in effect, it just makes our life so much easier. Right, now, having this, I'm looking at this stuff and I'm thinking, do I really like this as an edge for the other parts? Now, technically it's supposed to work, but you know, maybe I just don't like the character of that. I want to change it a little bit. Can I do it? Of course I can. So I will activate my curvature comp, and actually activate the I will activate the symmetry just in case. We can see the curvature comp. We're going to see how our modifications to this curve will change the plot. Now, what I want to do is I would like to expand to make these edge pushed away a little bit, so it will not be that flat, a little bit more of a crown, I would say. So I will use the proportional editing with just a standard linear fall off, and then I will push that, just kind of put it aside, I'll push it a little bit away. So while I'm doing this, I'm looking at this part, because I don't want a butt cheeks effect where these acceleration will diminish to the basically the flat parts. I don't want any flattened parts here. I want a constant acceleration across my object. So I don't know where it's supposed to go in terms of my own liking, but I believe this is good enough. I would say this is most likely the form I'm looking for. Well, let's say that's good enough for me. I believe I like it. Now it's natural, it's flowing, but I add some bias to that at this point. Okay, what else could I do? Maybe I don't like that aggressive acceleration. Maybe I want to make it, I don't know, a little bit less punchier. So let me use the proportional editing as well, and now I'll just slide it a little bit. Yeah, maybe something like that. So you see, as we already have the proper direction and the proper natural curve, we can tweak it a little bit using the constraints which we already have, right? I have a tangency constraint here, and I have already defined position for all of the CVs, and I can move them as a whole a little bit to slightly morph the shape to achieve the goals I really want. Maybe I want to have a slightly different shape, who knows, right? Okay, so now we created a curve, a surface. what am I going to do with this? Well, actually, I will do nothing. Instead, I will just duplicate the curve. I will use the duplicate command and I'll just delete it. I don't need it. I will do this curve properly a little bit later. What's important here, and the state step is important just to extract the edge. And we did this. So now we have an edge. We need another edge. So basically, we need to repeat the same steps as we did before. So I will use the rail tool, one generation, two rails. So let's do that. And just turn off the symmetry. All right, now we have another surface, and as you can see, we have literally the same problems. So it is not collinear, and across the center line, only the first and the last edges, everything in between does not. It's skewed, so it doesn't really follow the edge I'm really looking for, right? Let me show you. Here is the line, it's how it's bulging, and yeah, it's just not great. So what you're gonna do is to repeat the same steps, as I said. So activate the symmetry plane align, select our surface, delete the history for the rail, and here we go. Now let's try to fix it, the bend a little bit. So I will use the the planarize hole, and I will just planarize the holes. So now you can, there is an option for all U and V, or only U or only V. I just prefer do it manually myself, one by one. I don't know why. It's just oddly satisfying, you know. So we have this structure, and it looks like it's actually yeah, it's pretty natural from what we have. I may do some tweaking to that if I wanted to, but in general it looks pretty decent. Yeah, like for example here in the top, I'm gonna see that it's a little bit too aggressive in terms of the way how it just ends. I believe it's just a little bit too abrupt. Now it is, let me check this again and activate the symmetry. It is natural, but I believe that I will do the same thing as I did with the first curve. I'll just bias it a little bit. So I will take these row of CVs. I will use only, I'll probably use only one, like that. And then I will just slide it a little bit. Yeah, and let me push this one a little bit away. Maybe something like this. Maybe this is what I'm looking for, right? Now, when I did all of that, let me realign my, replanarize, I'm sorry, my holes, so that I'll be sure that it's actually does the right job. All right, here we go. Now, in case I wanna change my mind, in case I change my mind, I of course can tweak it later when I will do other parts. So this is not like set in stone. We can always go back and change some things and tweak some things. In fact, we will do it a little bit later. So now we have this surface, and that means that we have a second part. Let me just duplicate this, and now I have the proper edges for all my surfaces. Now I can actually use this one if I wanted to, but you know, just to repeat myself for a better understanding, let me just quickly rebuild this. So imagine that this is actually what you built, and now as it's all fresh and clean, you can actually start laying surfaces. Now once again, you don't necessarily need to delete the last surface, it was just good, but we always can rebuild it if we want it, because we have all the proper curves. So this time, and this is actually a good question, like what kind of tool to use, because now we have all four sides for all of the parts. So is it rail, or maybe now it is a square? Maybe it's better to use the square tool. Now, it really depends on the situation. In general, you need to think this way. If this is a patch, like you created something, you cut, rebuild, and you have some hole which you need to close, not relatively big size, and it's supposed to be natural to all of the other parts which are already created. The square tool is the best choice because it has a blend between the boundaries within the linear type. So the bias is always the same. So it is a linear blend between the first, second, third, and fourth boundaries. But in our case, we still need to maintain the flow, and we know that the flow goes like this. So from this to this to this and then to this. So once again, I'm using rail for that. But this time I will use 2 generations and 2 rails. So let me do that. That will be a rail. That will be the generation curve, another generation curve, rail, and rail. So which rail it will be doesn't really matter. So now we have our surface, and once again, if you look closer, you will notice that even though that it is accurate and straight right now, the tangency is not guaranteed again. In fact, there is no tangency again, so it's not a big deal. Let me quickly realign this, and bam, now we have it. Cool. Now next, if you look closer, it will realign the CVs, but now it's not straight anymore. So once again, we can always go in and just straighten the holes a little bit. Here we go. Good enough. At this point, we can consider this surface as a done deal. We still can tweak it a little bit in the future, but in general, this is a good surface to use as the main surface. Now let's do the rest. So the process is very simple. So 1 generation curve. Now I will use the rail, the edge of the surface, and that will be my generation curves, and the rails will be these ones. Here we go. Now when I did it, of course, same issues. It's not aligned, and it's not aligned here as well. So we have tangency deviation, and we have tangency deviation here as well. So we need to fix this. You already know what we need to do. So we can align it and then align across the center line, but basically it requires a few steps. So first of all, let's go for alignment. My position influence slider is set to 1. That means that Alias takes the full control over position of the CVs, and it will try to make them collinear at as good as it really can, instead of trying to keep the positions of the CVs at its current state, or once again as much as it can. So let me align. All right, now as you're gonna see, I have the curvature deviation of 0.07, quite small one, but I'm working with the tight tolerances, so for me it is an issue and I need to tweak it. But apart of that, if you look closer, we are lacking continuity across the center line. So before I will fix any of this, I actually need to work with the alignment across the center line. So let me now click on that again, delete the history, and now it's properly aligned across the center line. Let me actually quickly check it. Yes, it is continuous. And this one does not. So we have a deviation of 0.1 and 0.07 for tangency and curvature respectively. So now I can tweak it manually, or I can repeat the step second time. So basically do a second pass. And in fact, I believe it's a little bit easier for me to do. So I'll just quickly realign, and we have the 0.12 curvature here, but no tangency errors. Now let me flip this apart and check. We now break the tangency. So once again, as I said, second pass means we'll do this stuff second time. And we will take my rail surface. Here we go. Now let me flip that. Okay, now this is curvature. So now as you're gonna see, we minimized the tangency deviation a little bit, but I believe that the next modifications now, if we don't really want to bring more degrees to our surfaces, and If you watched me before, I mentioned it a few times that it's better than you have as little amount of degrees as you possibly can. It will be easier for you to create the more natural, beautiful, and organic surfaces. So I will try to solve it with the current structure, and in fact it's supposed to be quite simple. Now, first of all, what I'll probably do is I will planarize my holes using the closest boundary, like that, and it already significantly helps me. Now let's work with the tangency issue. So I'll pick this CV, I will go to direct modification of a CV, and I will probably move it along the normals just a little bit. Okay, and now we have this. I'm not sure that it really helps, so let me just try to make this one. Maybe this one will work. No, it doesn't, so let's keep working with this one. All right, cool. Now a little bit here. Okay. Right, now looking at the structure, I see that this point, this CV is actually kind of falls out of the line. Now the reason for that is actually the structure of the surface itself. As you can see, we have this kind of poking edge, and we have this somewhat like an aggressive transition. Now that was my intent, that's why I built the curves like that. But maybe I changed my mind and I want to make it a little bit more uniform. And for that, what I need to do is I need to tweak it, and as a result, the curvature will break again. But why not? We still can do that. So I'll probably put it somewhere here. Let me just turn off the shading and then push it back. Here we go. So now it's less punchier, but a little bit smoother. So as you can see, you can do some slight modifications to to adjust your surfaces, and it still will be quite organic. Now, if I will, let me just it looks like this one is a little bit falling off. Let me try to tweak it a little bit, maybe something like that. Now, we're not doing A-class here, so just me being crazy. If it was an A-class, then for sure you really need to do it and spend a lot of time making the proper arrangement of the CVs, but it's not the goal of this lesson. So now we have two surfaces. How about the last one? Let's do the last one. So for that, we need to repeat the steps. We already did it before, so I will use the rail tool, 2 generation curves and 2 rail. So this is my edge of the original surface. This is my first generation curve. This is my second generation curve, and 2 rails. Once again, I already said that the order of the rails is not that important. Okay, now it's obvious that we have some issues here. Now there is no collinearity, and the issues are literally the same. So let me first use symmetry across the center line. Then let me planarize my holes like this. All right, and then let me realign the surface as a curvature. Once again, position of line is supposed to be at 1. Okay, now let me quickly check. Did we? Yeah, we lost our continuity. So let me tweak this as well. So again, okay. So now we have a continuity, but now we lost continuity here on this edge. But it's a really minor difference, so we will fix this. So let me Let me push it a little bit here, and this one, maybe we're gonna move this a little bit. I'm looking at the black. It's probably difficult to see for the YouTube compression. I'm looking at the marking of the I forgot how it's called. 1 second. Marking of the spacing, the marker of the per span checker. So you're gonna see there this, I believe they are an orange color, and the black one marks the last acquired deviation. So nonetheless, so it is curvature. Now, if I look closer here, I will notice that we have this, well, tail, I would say. As these this part is really narrow, it forces the CVs to, well, follow. Now, this is your intent, that's great. To some extent, it's my intent, so because I built that, but I still want to tweak it a little bit. So I'll probably move that a little bit like that to make it softer. And this one I will push away a little bit. And it's definitely, oops. Let me just do just a little bit more like this. All right, okay. So that's basically it. Now we created all the pieces, and here we go. Let me just activate the zebra stripes and look closer of what we get in return. Now, one important note I already mentioned before, this is not technically an A class to do, but this is really good for as a starting point. So you started with your concept design, you have your sketch, you created the proper curve network, or you created the surfaces, and then if you pretty much happy with the surface you have, you're happy with the kind of this somewhat like an aggressive kind of pinch on the sides, right? Which actually look quite cool. I like it. Then you just kind of go in and use the cross-align approach on already created surfaces, so these one and these one, and just tweak them a little bit so that the continuity will be better, but it's not bad here as well, so it's pretty decent. And if you look closer and notice that we have these kind of parts of the flatness where we have a little bit of a, I would say, I wouldn't say that this is a dimple, but very gradual, almost linear transition. Well, that's because of these curves. So if these curves will be different, the transition will be different. So of course, this is a back and forth process. You did it, you like it or dislike it, you go and you refine it a little bit. But when you already have the proper curves, now it will be much easier to tweak the curves a little bit, because you know that they are pretty much in the proper spots to change the look and form of our shape. Like here, for example, you may think like, well, that's too much of a bend. Maybe I need to, push this edge a little bit up. That's not exactly maybe what you want. Who knows? But once again, now when you have all the curves, it become to be much simpler and easier to achieve. And let me just quickly check to prove that everything here is curvature. All right, so this is basically how you construct the flow of the surfaces using a curve network. So as a conclusion, guys, one of the most prominent things in NURBS modeling is your curves, because curves will define how your surfaces will lay on the, or basically fill the gaps. And as the surface is the final result for you, the curves are so important, because without them, without the proper curve network, you will not get the proper flow, no matter how hard you try. Now, you can just randomly place some curves, and then through a lot of heavy modifications of the surfaces, basically manual CV massaging by kilometer, just slowly but surely eliminating the errors. But it's very, very long process and just doesn't really make a lot of sense. So use the power of the Alias and use your curves, use your curve networks to create the proper flow. Right, and that's it for this lesson. Thank you very much for watching, and I will see you in the next one.